Hi, let's go ahead and do chapter 2 practice problems. So, right now I'm going to start with question number 1. 25 randomly selected students were asked the number of movies they watched the previous week. The results are as followed: 5 watched 0 movies, 9 watched 1, 7 watched 2, 3 watched 3, and 1 watched 4. Construct the histogram. All right, so the first thing I want to do is I want to go ahead and find in the, the 0, which equals 5. That equals 5. That doesn't equal 5, so that's not one of my choices. That equals 5, and that equals 5. All right, the next one I'm looking for is 9. That equals 9. That does not equal 9, and that one equals 9. So I've gotten rid of this one over here and this one here. So then the next one I'm looking for is 7. That doesn't equal 7. That equals 7. So then I'm going to quickly just say, okay, for 3, that's 3, and then 4, that's 1. That is my correct histogram. So I'm going to mark that. All right, the next step it wants me to do is it wants me to calculate my relative frequencies. So if I add up all my numbers together, 5 plus 9 plus 7 plus 3 plus 1, I get 25. So my first relative frequency is 5, which I get from here, divided by 25. Okay. For the next one, it's 9 divided by 25. Next one is 7 divided by 25. Next one is 3 divided by 25. And the next one is 4 divided by 25. Okay. All I did is I got here, I got the 5 from here, and the 25 from all of them added together. Cumulative frequency, for this one, it's going to be 5 divided by 25. And then for this next one, I'm going to add 5 plus 9 gives me 14. Divided by 25. Okay. Next one is 21 divided by 25. Why? 5 plus 9 plus 7 gives me 21. This one is 24 divided by 25. And this one is 25 divided by 25. So that's how you do those. Okay. That's how you do the frequencies. This one's a little bit trickier, so let's go ahead and go into this. So I have 3 box plots. This is not a very good box plot up here. I'm going to tell you that now because I don't know if the box itself is here or here. I'm assuming it's down here because this is so close between 0 and 5. So for Germany, it's saying that 50% of the data is from 0 to 8 and 50% is 8 and above. For the United States, it's saying 50% is 2 and below, and 2 and above to 11 is 50%. So, complete the sentences, describe what shape of each box plot implements on the distribution. All right, so let's look at this together. All right, so I'm going to say this would be the upper 25% for China with the 75% here. So I'm going to say that 75% of Chinese participants have never visited a foreign country. So then that's going to make my data skewed to the right. Because if 75% of my data is right here, that means 75% of the data is to the right of it. Okay, the lower 50% of the data for the Germans is more spread out than the top 50%. And how do I know that? That middle line is my median. So the median is 50% of the data. So this is here to here, and this is here to here. So I'm going to say since 50% of my data is down here, that makes this is skewed to the left. Okay. The data for the US participants is skewed to the, all right, so how would I figure this out? So here's 50% right here, and here's 25, and that's 25 there. So this is actually skewed to the right. Why is it skewed to the right? 75% of my data is 5 and below. So that's how you would figure it out. Okay. Have a greater proportions of American or German surveyed been to over 8 foreign countries? So I'm here looking at 8. So because this to this is 25%, so it's roughly half of 25%. But for the Germans, this is the median, which is 50. So 50% of Germans have been to 8 or more countries. So I'm going to say the Germans. Okay, part C. All right, so let's try to fill in the boxes. Compare the 3 box plots. What do they imply about foreign travel for 20-year-old residents of 3 countries when you compare each? According to the box plots, which country do they rarely go outside their home country? And remember, we found that in China, all right? All right, 20-year-olds in blank travel a great deal. Well, if we look at that, it looks like in Germany, they travel a great deal because remember, 75% and above have gone 4 to 8. So I'm going to say this is Germany. So then it says the greatest variability is seen in blank, where 25 have never been outside the US and 25 have traveled to at least 5 foreign countries. So here's 25% that have never been out of the US, and then here's 25% that's been out 5 or more. Okay, so that would be the United States. Okay, so that's how you do that problem. All right, for this one, this is a little bit trickier. These can sometimes throw you, so I'm glad we're doing a video on this. All right, so I'm given some population parameters for full-time equivalent number of students at a community college. So my mean is 1,000 students. My median is 1,014 students. My population standard deviation is 47. My first quartile is 528.5 students, and my third quartile is 1,447.5 students. And my sample size, my sample size is 29 years. A sample of 11 years was taken. About how many are you expected to have of the number of students of 1,014 or above? All right, so what would I do for that one? So I'm going to multiply 11 times, let's see. Okay, oh, I'm sorry, I did that wrong. Median means half, right? So your median is 50% of the data. So if I do 11 divided by 2, I get 5.5. Well, it wants it as a whole number, so that's going to be 6 years. How did I get that again? All right, so the median is 50% of the data. So I had a sample of 11 years. So I'm going to divide 11 by 2, and I get 6 years. So 6 years would give me roughly 50% of the data. I know that it's 5.5, but they wanted me to round up. All right, so how am I going to explain this? So since 1,014 is the median value of the population parameters, this value is the middle value. Remember? It's the 50th percentile of your data in the order list of your data values. The value in this series of 11 will be the 6th number. Therefore, 6 years will be your total. Okay. So think about it. If I put down 1 through 11, if you go look at it, number 6 is the middle number. So that's how you have to think of that. I know it's the wording's kind of weird, but that's how you put it together. All right. The next one. All right, this one throws people a lot too. Same data. 75% of all the years have a FTES in the following ranges. All right. Well, I'm given a mean, and you cannot assume anything about your mean because your mean can be skewed. My median tells me my 50 percentile, but I really want 75% of my data. So, okay, I know my first quartile is 25%. So I know if I hit at least the bottom of my quartile, I have 25%. So I want to put, I'm going to put this, let's see, hold on. My computer's acting up. So I want it at or above. So I'm going to put this 528.5 because this is my first quartile, which means 25% of the data is below it, but 75% is above it. All right. So then I want to know that next for at or above. Well, I know that my third quartile means that 75% is below my third quartile. So that's why I'm going to put my third quartile here. So what I'm saying here, if I'm below my third quartile, I'll get 75% of the data. If I'm above my first quartile, I'll get 75% of that data. That's what that's just saying. It's not worded very well, but that's what it means. All right, so next one. What percentage of the students were from 528.5 to 1,447.5? All right, let's go look at it. So again, I'm using my quartiles. So I'm from my first to my third quartile. So 25 to 75 is 50% of the data. So 50% of the data occurs between there. So how do I know that? The values are the first and third quartiles. So 50% of the data is in that range. If that didn't make sense to you, go ahead and go back and look at the videos I made about all that kind of stuff. All right, so now I need to put the stuff in the calculator. All right, I'm bringing up my calculator. I'm going to clear it out. All right, let me show you how to do these. I'm not worried about the years on this. This is not a weighted mean. This is just regular 1-bar statistics. So I'm going to go to stats. Oops, excuse me. Stats. I'm going to hit enter. And then I'm going to put 1585. 16. Okay, all I'm putting is the students. I'm not putting in the year ranges. They don't want to know anything about the years. They just want to know about the students. So I'm just going to put my values in my calculator. And as you can see, I'm just going straight down, and I have a couple of videos on this. So this really shouldn't be that bad if you need help with this. Okay, and then 1890. Okay, so I have all 6 data values in there. As you can see, I put the data values on the bottom, going down here. Then I go stat, go over to calc, and I hit enter, and I hit enter. Okay, what's my mean? And it wants it in 1 decimal place. So my mean is the first thing I see. This one is 1809.3. So I'm going to do 1809.3. Okay, my median. So I'm bringing back up my calculator. So if I scroll down, it says my median is 1812.5. Okay, now it wants my standard deviation. I'm going to go back up. Okay, be careful on your standard deviation because it gives you 2. It gives you a sample standard deviation. It gives you a population standard deviation. This is said population, so use the population one. So this is going to be 151.2. What's my first quartile? Great thing about the calculator, it gives it to you. Here's first quartile, 1690. So I'm going to put 1690. My third quartile. So I'm going to keep going down. 1935. And then my IQR. So what is my IQR? So I don't get it, and the calculator didn't give it to me. So what I can do, though, is I can do 1935 minus 1690 equals 245. So that's my IQR. That's just the difference between the first and the third quartile. So 245. So that's how I answer those questions. I'm going to do another video for this one, which is best estimate of mean percentage, so that it'll be easier to understand. Thanks. Let me go ahead and get out of this video. Okay. Sorry about that.